In this video, I'm going to do something different. Up until now, I've been sharing concepts in more presentational format, but from time to time, I want to see those concepts in action. Today is one of those days. Today, I'll build a project that will serve as the backbone for future videos like this. I'll use IOC and dependency injection principles to show you how to work with VContainer in a real-life project. Just a heads up though, I won't focus on performance or all the best practices. I'll leave those for future videos. Today, the focus is VContainer. First things first, let's see what we're actually building. This is a simple 2D shooter. We have targets spawning randomly at predefined locations, and our spaceship can rotate and shoot them. Targets spawn for a limited time. If you manage to shoot down a target while it's alive, you earn points. But if the target despawns before you hit it, points are subtracted from your score. Since we're concentrating on the code aspects, I'll skip the scene setup part. As you can see, we already have some assets and game objects in place. I've created the prefabs ahead of time, but none of them have scripts yet. They don't do anything. To go over things quickly though, here's the background and the walls. They're just sprite renderers with colliders. Let's start by installing VContainer. There are lots of options. You can install it via Git URL as a package, but I prefer to install it directly from OpenUPM using their CLI tool. While we're at it, I'll also install the Unitask package. As a rule of thumb, I always use Unitasks for asynchronous code in Unity. We'll have a separate video about that. Now, what these commands do is modify the manifest.json file, which you can find in the packages folder. So, if you struggle to install the packages via CLI, you can just add the following lines manually. It adds the scoped registry section that tells Unity where to search for these packages when they're requested, and then there's the actual request to install those packages with specific versions. Next, inside the code directory, we'll create an assembly definition file. You can do it from the Unity editor as well, but whenever I can, I prefer to work in the IDE. I always recommend using assembly definitions. When your project grows, they'll help you a lot. They'll save you from circular dependencies and shorten your compilation times. Now that we're done setting up the project, we can move on to actually writing some code. In a big company, you'd usually start by planning and writing a design document. I've done that already, so we can skip this part. And since I already know the architecture, I'd like to start with interface definitions. I love working this way because when I start writing implementations, I can already reference other systems even though they haven't been developed yet. I'll start with IInputHandler. It will be able to tell me whether there was any input during the last frame. And since we're talking about input, we'll need a way to configure it. We'll map some buttons in the iControl settings interface. We'll need rotation direction buttons and a fire button. We'll also have a player controller. At the moment, I don't think we'll need to expose anything in player controller to the outside world, but it's good practice to use this interface for future-proofing. And if we have a controller, let's have a view. We need rotation, and we want it to be as agnostic as possible. Today, the whole ship rotates, but who knows what implementation we'll have tomorrow. I also want to have a time service. It's useful to have only one entity in the game that counts time. This prevents potential time desynchronization. And since it's a game, we need some way to keep track of the score. I'll add the ability to add and subtract score and to notify anyone interested when it changes. We need a target. So let's create a target view. We want to be able to notify when the target gets hit, we want to spawn and despawn it, and we want to know if the target exists at the moment. And since our views should do only presentation stuff, we'll need a controller that actually controls the target. Among other things, it will be responsible for forwarding hit and despawn events. You might notice that this controller expects view initialization. This is a bad practice because I'm forcing a dependency at the interface level. I had to go with this for sake of simplifying the current example, but we'll revisit this in the future. I also want to create a bullet view that doesn't implement any interface. This is just to show you that DI works with monobehavior classes, and you don't even need interfaces if you don't want them. For now, it's just an empty class. We'll add the implementation later. We'll also need a service to spawn and despawn our bullets. It's really useful to centralize these kind of things if you plan to have more than one entity sharing the same pool of objects. And I think I want our game to be configurable, so I'll create configurations for some aspects of the game. Things like points for hit or miss, rotation speed, and target spawn duration and cooldown. Last but not least, I'll create a lifetime scope. As I said in a previous video, lifetime scope is the place where you tell VContainer how to resolve dependencies. For now, we don't have anything to register, so I'll leave it empty. Now that we've finished creating our contracts, let's dive into our first implementation. It'll be a hello world of sorts. I'll implement the input handler first. We know that we'll need control settings, so let's request them in the constructor. The fire button is easy. We just check for input get key down while passing it the key from our settings. With direction, we'll need to do a bit more work since we're converting two different inputs into a float, and I don't want to use the get access method. I'll go with this fancy switch expression syntax. No particular reason, I just like how it looks. By the way, notice how we don't have the settings implemented yet, but we can still reference the interface and work with it? Since we're at it, let's implement the settings. Scriptable object works great here. We'll be able to easily tweak parameters in the editor. When I need to expose scriptable object fields to the outside world, I like using this field serialize field syntax. It tells Unity to serialize the backing fields of the property, which is pretty neat and makes the code a bit shorter. Let's finish with the player controller. We'll need a constructor and interface implementation. I'll also implement the iTickable interface. This is one of the interfaces that comes with VContainer. It lets regular classes receive Unity lifecycle callbacks. Why use it? Performance mostly. Monobehaviors are complex objects and bring a lot of overhead you don't see. If our class can do the same job without that overhead, we can opt to a simpler solution and thus improving the performance of this particular module. The tick method runs every frame just like update would. For now, we'll just log the aim direction and fire button when they're pressed. Nothing fancy yet. So far, we've only created classes and interfaces. Let's wire them together. First, let's reference the control settings. Since lifetime scope is a regular monobehavior, we can use serialized fields here. Next, we'll register the input handler. This tells VContainer that anyone requesting input handler should receive a keyboard input handler instance. Since it's a singleton, it will always be the same instance. VContainer will lazily create the keyboard input handler when first requested and automatically inject all its dependencies. If it can't resolve a dependency, you'll get an exception. Back to control settings. Let's register it. Because we already have an instance, we use register instance method instead of lazy creation. And then we tell VContainer to use this instance whenever someone asks for control settings. Finally, we'll register player controller as an entry point. Remember that iTickable interface? Entry points are how VContainer knows to call those lifecycle methods on regular classes. Let's head to Unity. First, let's add our game lifetime scope to the scene. Then, we need to create the settings. Notice how our properties are serialized just like regular serialized fields? Finally, we need to reference our settings in the lifetime scope. Let's see what we've got. When I press the fire button, we see a log saying fire button pressed. When I press the direction button, we see the direction value. Great start. Logs in a console are great and all, but they're not exactly fun to play with. Let's make something visible happen. I'll update the player controller dependencies. We'll need the game settings and the view we're going to control. Let's replace that direction log with actual rotation logic. Notice how we don't have the player view implemented yet, but we can still write the logic that depends on it. Since we know we need the game settings already, let's implement them as well. I'll do the same thing I did with the control settings. I'll implement the interface, and I'll serialize the properties themselves. And now for our first functional view. In this scenario, view is a regular monobehavior. So let's implement the interface, and then we can serialize the transform of the cannon. In the getter and the setter of our cannon rotation property, we manipulate the Euler angle of the cannon directly. And that's it for the view. Nice and simple. Before we jump into Unity to see our rotation in action, let's update the lifetime scope. We'll need some references again: the game settings and the player that's already in the scene. I'll register the game settings as an instance, but this time I'll use the generic overload, just to show you both ways. And finally, let's register the player. Here I'll use the register component method. Internally, it's really similar to instance registration, but it has an additional function. It tells VContainer that we need to inject dependencies into this component. Our player view doesn't actually need any dependencies injected. But hey, we're here to learn how VContainer works, right? Now back to Unity to finalize the rotation. Let's create our game settings real quick. As I said earlier, I prepared the prefabs in advance. Here's our player. Nothing special. Just a sprite renderer in a hierarchy that honestly could have been simpler. I'll attach the view script to it, and I'll populate the canon field. Let's drop it into our scene, and I need to fix the position real quick. Now update the lifetime scope, and after running the game, we should see the spaceship rotating instead of just logging directions to the console. Remember that bullet view we've created earlier? Let's actually do something with it. We'll need some serialized fields. Speed, that in full honesty should be moved to the settings, and the reference for a rigid body. Since it's a mono behavior, we can't use constructor injection here, so we'll use method injection instead. If we instantiate this component through our container, any method marked with the inject attribute will be called even before awake. The bullet is a simple entity. It doesn't need a controller, at least not yet. It should fly forward when spawned, and stop existing when it hits something. Anything. But since we don't want to handle the destruction creation internally, we'll let the service handle this for us. In the start movement method, I'll write the logic that sets the bullet's trajectory. I'll let anyone trigger this logic, but let's also call it during onEnable just to be safe. Finally, when the bullet collides with something, we'll ask the bullet service to despawn it. Now we can create the service that will handle all of the bullet's logic for us. We'll need a reference to the prefab and to iObject resolver. This interface is part of VContainer, and it's registered automatically. It's basically a service locator inside DI. Sometimes we need to resolve dependencies at runtime because we don't know beforehand what or how many we'll need. We'll also need a pool. I'll use Unity's object pool, even though I have some criticism of their implementation. The magic happens in the createBullet method. Notice that I use the iObject resolver to instantiate the prefab. In the background, it performs the usual object instantiation, and then it injects the dependencies if they need it. I'll need to implement the other pool methods as well. When the bullet is spawned, I'll set its position to the same of the spawn point, and when it's released, instead of destroying, I'll just disable it. Last thing, I'll implement the interface methods. The despawn method will release the bullet to the pool, and spawn method will fetch it from the pool and set its movement direction. Now, there's a logical issue here. In our constructor, we're requesting a transform injection. While this works fine if there's a registered transform in the container, any transform could have been registered there. What we need is to specify exactly which transform we want. There are many ways to do this, but recently, my PR adding keyed registration got merged into VContainer repository, so let's go with this solution. First, we'll need a key. The key can be anything. It can be a string, it can be an object, but I'll use an enum. After creating it, we can go ahead and specify that the transform we need is registered with this particular key. Now we can update our player controller so it can shoot bullets. First, let's add the bullet service dependency. Then, we replace the log with an actual bullet spawning logic. We calculate the direction based on the cannon's rotation and spawn the bullet in that direction. As always, before any milestone, we need to update the lifetime scope. We need a bullet prefab and a spawn point for the bullets. There's nothing special about the bullet service registration, but take a look at how the spawn point is registered. By invoking the keyed method, we're telling VContainer that this instance should be registered with the bullet spawn key. Let's also register the prefab as an instance. Notice that I don't provide a type to register it as. VContainer will use the type of the object we're passing, bullet view in our case. And once again, I have the bullet prefab prepared beforehand. It has a collider, a rigid body, and two sprite renderers, one for the bullet itself and the other for the trail. Let's add the view script and drag the rigid body to it. Now, let's drag this prefab to the lifetime scope. On our player, we have a spawn point that rotates with the player. Let's drag it to the lifetime scope as well. Now we can run the game, shoot bullets, and see how they fly in whatever direction the spaceship is facing. We haven't implemented fire rate limiting, but who wants that anyway? Take a look at the walls. When bullets hit them, they disappear. That's because colliding with anything triggers the despawn logic. And since we're using object pooling, we don't need to instantiate or destroy bullets constantly. They're just enabled and disabled. Our game is almost done. We just need some targets to shoot at. This means that I need to implement the target controller. Here's another great thing about VContainer. It automatically calls the dispose method for any registered class that implements iDisposable when the container is destroyed. And yes, we can have multiple containers with their own hierarchy, but we won't get into that today. I'll skip the implementation of this class since most of the work here is not really related to VContainer. I'm setting the view, implementing target spawning, despawning it after a certain time if it wasn't hit, and triggering events when the target gets hit or despawned. Actually, the majority of the code here is related to despawning after a certain amount of time. As I said in the beginning of this video, I like to use the Unitask package for anything asynchronous in Unity. And we'll have a separate video on that as well. If you'll want to see the whole thing, I'll leave a link to the repository in the description. I'll keep it updated with the latest videos, but I will also keep a separate branch for every video I do. Now for the target view. As always, I try to keep views as simple as possible, only presentation logic. We have a target, an asteroid in our case. We show it when it spawns, and we hide it when it despawns. We trigger an event when the target collided with something, and we also enable and disable the collider so when the target is inactive, bullets will fly through it. And now for the target service. It'll be an entry point. iStartable is another VContainer interface. Entry points with this interface get their start method code similar to MonoBehaviorStart. Here's something interesting. We're requesting an IEnumerable of target views. When multiple instances of the same type are registered in the container, we can request them as a collection and get all of them. In addition to the collection of views we receive through an injection, we'll need to hold an array of controllers as well. Another interesting thing happens in the start method. We use iObjectResolver to resolve instances of iTargetController. So far, we've only registered singletons or existing instances, but VContainer has other registration types. Here, I'm expecting a transient registration, meaning each time we request this dependency, a new instance is created. And it doesn't matter if we request it via iObjectResolver, constructor, or any other way. Next, we set the view for each newly created controller and subscribe to its events. We also subscribe to the time service. We'll try to spawn a new target for each second that passes. And of course, we unsubscribe from everything when the object is disposed. Last thing, we'll need a time service. It'll be super simple. It's just an iTickable entry point that triggers an event every time a second passes. Finally, before we have working gameplay, let's update the lifetime scope. First, I'll serialize the collection of target views to register a bit later. And I'll register the target's controller. This time, not as a singleton, but as a transient. As I said earlier, this tells VContainer to create a new instance every time someone asks for one. To register multiple instances of the same type, we need to provide a key for each registration. Here, I'm using the game object's name, but honestly, this isn't safe. If names are duplicated, it'll break our code. Lastly, I'm adding two entry points, target service and time service. and I want time service to be resolvable through its interface. Back in the editor, I've already created the spawn point prefab. Once again, just a collider and a sprite renderer. Let's add the target view component and populate its values. Next, I'll drop the spawn points randomly across the scene. I'll duplicate them and just change the position. And I should also assign all of them to the lifetime scope. I'll just lock the view and drag them here. And that's it. Our gameplay is complete. Let's see it in action. Targets spawn randomly, and after a while, they will disappear. We can see logs for despawned targets, and if I hit one, it disappears with a log saying that the target was hit. But the game isn't complete yet. What kind of a game doesn't track score? The score system is pretty straightforward. The only dependency it will have is the game settings, to fetch the amount of score we're adding or subtracting. Other than that, we're holding an integer, updating it with values from the interface methods, and triggering the score changed event on each one of them. Back in our target service, we'll request the score service as a dependency. Now we can remove those dummy log methods and wire up the real score system methods. And I'll update the dispose method as well. We need to display the score somewhere. So let's create a UI view. Usually, I'd find a better naming, but in this example, it's good enough. While we're at it, let's also display how much time has passed since the start of the game, for no particular reason. For that, I'll need the time and the score services. I can request them via method injection in the construct method, and in awake, I'll subscribe to their events, just to show that awake runs after injection. Each second, I'll update the time text with the total amount of time since the start of the game, and when the score changes, I'll update the score text with the current score. Of course, I shouldn't forget to unsubscribe from everything when the object is destroyed. And here's the final line of code of this project. I'll leave this one unexplained. What's left is to update our final prefab. It's an empty rect transform with two TextMesh texts as its children. I'll add the UI view component to it and assign the text elements. Now save the prefab, place it on a scene, and I need to fix the alignment a bit. Now for another trick. UI view expecting injections. But I haven't registered it anywhere and I don't instantiate it dynamically through iObject Resolver. VContainer is built with performance in mind, so it doesn't scan the whole scene to check if someone needs a dependency. We have to manually specify that this object expects injections. The way to do it is to put it in the auto-inject game objects collection on the lifetime scope. Let's run the game one last time. In the top right corner, you can see the timer updating every second, and in the top left corner, you can see the score updating as well. In this workshop, I've tried to dive deeper into VContainer as a framework. I structured the project to showcase as many features as possible, even though sometimes the approach wasn't ideal. With that in mind, I'm far from covering every aspect of the framework, but I think it's a great start. From here, you can dive deeper into the documentation, or even choose another DI framework as your go-to. The concepts we covered are pretty universal. I'll leave a link to the code in the description. In future workshops, I'll expand this project even further to apply concepts from my other videos. If you feel like it, hit the thumbs up and maybe even subscribe. Keep on creating, and I'll see you in the next one.